The universe is an endless enigma, a place where reality bends and twists in ways that often defy our wildest imaginations. Out there, beyond the glow of our familiar night sky, cosmic events unfold that make even the most seasoned astronomers pause in stunned silence. Picture this: a star suddenly vanishing without a trace, a black hole spinning so fast it warps the fabric of space-time, or a mysterious radio signal repeating from deep space with no clear origin. These aren't scenes from a sci-fi blockbuster, they're real phenomena, observed by telescopes and left scientists scrambling for answers. And today, we're diving into 25 of the most bizarre cosmic events ever recorded, each one stranger than the last, each one rewriting what we thought we knew about the cosmos. What makes these discoveries so thrilling isn't just their sheer weirdness, it's what they reveal about the universe's hidden rules. For every law of physics we think we understand, there's an astronomical oddity out there laughing in its face. Take, for example, the case of a galaxy spinning the wrong way, defying all predictions, or a planet so dark it absorbs nearly all light that touches it. These aren't just quirks, they're cosmic puzzles, clues that could unlock deeper truths about how everything, from the smallest atom to the largest supercluster, fits together. And that's what makes this journey so gripping. You're not just watching a list of strange space events, you're getting a front row seat to the moments that forced scientists to rethink everything. So if you've ever stared up at the stars and wondered what secrets they're hiding, you're in for a treat. Over the next few minutes, we'll travel across the cosmos, from exploding stars that shouldn't exist to bizarre celestial objects bending the very laws of nature. Some of these events are beautiful, some are terrifying, and some are so perplexing that researchers still argue about what they actually witnessed. But one thing's for sure: by the end, you'll see the universe in a whole new light. Ready to have your mind blown? Let's begin. One of the most electrifying moments in the search for extraterrestrial intelligence came on August 15, 1977, when a radio telescope in Ohio picked up something extraordinary. For 72 intense seconds, a powerful narrowband signal blasted through the static of deep space, so unusual that astronomer Jerry Amon circled it on the printout and scribbled, "Wow," in the margin, giving the event its iconic name. This wasn't just background noise. The signal matched the exact frequency scientists predicted aliens might use to communicate, and it came from the direction of the Sagittarius constellation. But then silence. Despite decades of searching, the signal never repeated, leaving researchers with a tantalizing cosmic mystery. Was it a message from an advanced civilization? The signal's characteristics were uncanny. Unlike natural cosmic static, it was focused, intense, and vanished as abruptly as it arrived. But skeptics point to alternative explanations, maybe a passing comet's hydrogen emissions or an exotic stellar phenomenon we don't yet understand. The truth, even today, no theory fully explains the WOW signal's bizarre profile. It's a cosmic one-hit wonder that refuses to give up its secrets, fueling debates at scientific conferences and sci-fi imaginations alike. What makes this event so haunting isn't just its mystery, but its timing. The signal appeared during humanity's first serious attempt to listen for alien civilizations, as if the universe was teasing us with a single cryptic clue. The original telescope, nicknamed Big Ear, no longer scans the skies, but its discovery remains a beacon. Whether it was an alien greeting, a fluke of physics, or something even stranger, the WOW signal reminds us that the cosmos still holds whispers we're only beginning to hear. While the WOW signal teases us with the possibility of alien messages, another cosmic mystery plays out in plain sight yet remains just as baffling. Meet Tabby's star, officially known as KIC 8462852, a seemingly ordinary star in the constellation Cygnus. But there's nothing ordinary about it. In 2015, astronomers noticed something bizarre. its light was flickering erratically, dimming by as much as 22% at times, a drop so extreme it defied all known explanations. Stars don't just dim like this. Planets passing in front might cause tiny, predictable dips, but Tabby's star behaved like nothing we'd ever seen before. The internet erupted with theories, from swarms of comets to something far more sci-fi alien megastructures harvesting the star's energy. The star's namesake, astronomer Tabby was the first to spot these anomalies in data from NASA Kepler Space Telescope. The dips weren't just irregular, they were chaotic with no repeating pattern. Some lasted days, others weeks, and the changes were too dramatic to blame on planets or typical stellar activity. Scientists scrambled for answers. Could it be a colossal dust cloud, a shattered planet's debris, or, as some daringly suggested, a Dyson sphere, a hypothetical alien-built structure designed to capture a star's energy? Even today, no single theory fits all the data perfectly. What makes Tabby's star so captivating isn't just the mystery, it's how it highlights the limits of our knowledge. Stars are supposed to follow predictable rules, but this one dances to its own erratic rhythm. Recent studies lean toward natural explanations, like uneven dust rings or swarms of icy fragments, but the truth is still out there. Every new observation adds another twist. In 2017, the star dimmed again, and telescopes worldwide turned to watch, hoping for clues. The more we learn, the stranger it gets. Here's the real kicker. This isn't just about one oddball star. Tabby's star forces us to ask, how many other cosmic anomalies are we missing? If something this bizarre slipped through our models, what else is hiding in plain sight? Whether it's aliens, dust, or something entirely new, this star reminds us that the universe is far weirder and more wonderful than we ever imagined. For decades, a shadow has lurked in Earth's orbit, not of this world, some say, but a relic from a civilization far older than our own. The so-called Black Knight satellite has sparked wild theories since the 1950s, with claims ranging from a 13,000-year-old alien probe to a secret government spacecraft. But here's where things get interesting. This myth blends real space oddities with outright fiction, creating a cosmic detective story that's as fascinating as it is misunderstood. The legend began with fragmented reports. In 1954, newspapers briefly mentioned unidentified objects spotted by the U.S. Air Force. Then, in 1960, a mysterious dark mass appeared on radar during astronaut Gordon Cooper's Mercury mission, though Cooper himself later dismissed it as equipment glitches. But what cemented the myth was a series of eerie photographs. In 1998, astronauts on the space shuttle Endeavour captured images of a strange, angular object floating near Earth, which conspiracy theorists seized as proof of the Black Knight. The truth, it was a thermal blanket lost during a spacewalk, tumbling harmlessly in orbit. So why does this story persist? Part of it taps into our love for cosmic mysteries. The idea that an ancient civilization or extraterrestrial visitors left something behind is undeniably thrilling, but the real science is just as compelling. Earth's orbit is crowded with debris, old rocket parts, defunct satellites, even tools dropped by astronauts. Some of these objects, like the 1964 Echo balloon satellite, reflect sunlight in eerie ways, creating illusions of otherworldly craft. Yet none match the Black Knight's sensational lore. Modern astronomers have put the myth to rest. Using radar tracking, they've catalogued nearly every sizable object orbiting Earth, and none resemble the described alien artifact. Even the famous 13,000-year-old claim crumbles under scrutiny. It stems from a misread newspaper headline about a scientist studying Ice Age cycles, not satellites. But here's the twist. The Black Knight's legacy isn't just about debunking. It reveals how easily the unknown can spark our imagination, turning mundane space junk into a canvas for cosmic storytelling. Ultimately, the Black Knight satellite is a mirror. It reflects our yearning for discovery, our hunger to believe there's more out there. And while this particular myth may be grounded in fantasy, the real universe offers no shortage of genuine enigmas waiting to be uncovered, one orbit at a time. Now imagine a signal so powerful it can outshine an entire galaxy, but only for a fraction of a second. Fast radio bursts, or FRB, are among the most explosive puzzles in modern astronomy. These fleeting cosmic flashes pack more energy than our sun emits in 80 years, yet they vanish almost instantly, leaving behind more questions than answers. First discovered in 2007, FRBs last just milliseconds, but their sheer intensity has astronomers scrambling to explain what could possibly produce such a brief, violent blast across the universe. What makes these bursts even stranger is their unpredictability. Most FRBs strike once and never repeat, like cosmic lightning. But then there's FRB 121102, the first repeating fast radio burst ever detected. Unlike its one-time counterparts, this signal from a dwarf galaxy 3 billion light-years away has fired off multiple bursts since its discovery in 2012, sometimes in frantic clusters. The pattern is chaotic, with no discernible rhythm, ruling out simple explanations like colliding neutron stars. Could it be a young, hyperactive magnetar, a highly magnetic neutron star? Or something even more exotic like cosmic strings or, dare we say, evidence of advanced alien technology? The hunt for FRBs is a race against time. Telescopes like the Canadian Hydrogen Intensity Mapping Experiment, or CHIME, scan vast swaths of sky daily, hoping to catch these ephemeral flashes. When an FRB is detected, observatories worldwide pivot to pinpoint its origin. Some bursts trace back to distant galaxies, while others seem to come from nowhere familiar. The real challenge: FRBs travel through cosmic gas and dust, distorting along the way. By studying how the signal stretches, astronomers can map the invisible matter between galaxies, turning these cosmic enigmas into tools for probing the universe's hidden structure. Why does this all matter? FRBs aren't just celestial oddities. They're windows into the universe's most extreme environments. If magnetars are the culprits, they could reveal how matter behaves under crushing magnetic fields. If the repeating bursts hint at unknown physics, they might rewrite textbooks. And yes, while alien megastructures remain the most thrilling, if unlikely, explanation, the very fact that scientists entertain the possibility shows how little we truly understand. Every new FRB discovery peels back another layer of the cosmos's mysteries, reminding us that even the briefest signals can carry the weight of the universe's secrets. In October 2017, astronomers made a historic discovery, an object hurtling through our solar system unlike anything we'd ever seen before. Named Oumuamua, Hawaiian for scout or messenger from afar, this mysterious visitor wasn't from our cosmic neighborhood. It was the first confirmed interstellar object ever observed passing through our solar system, arriving from the depths of space and leaving scientists utterly captivated and deeply puzzled. Right from the start, Oumuamua defied expectations. Most asteroids or comets follow predictable, elliptical orbits around the sun, but Oumuamua was different. It screamed into our solar system at breakneck speed, moving too fast to be bound by the sun's gravity. Its trajectory suggested it came from the direction of Vega, a star 25 light-years away, though it had likely traveled for millions of years before reaching us. But the real shock was its shape. Based on brightness variations as it tumbled through space, astronomers determined it was long and narrow, roughly 10 times as long as it was wide, resembling a cosmic cigar or a pancake. Nothing in our solar system looks quite like this, raising immediate questions about its origins. Then came the strangest twist. As Oumuamua slingshotted past the sun, it didn't just coast away as expected, it accelerated slightly, as if pushed by an unseen force. Comets sometimes speed up due to outgassing when solar heat vaporizes ices, creating a jet-like effect. But Oumuamua showed no visible coma or tail, the telltale signs of outgassing. Some researchers proposed it might be made of exotic hydrogen ice, which could vaporize invisibly. Others suggested it could be a porous, lightweight dust iceberg releasing trapped gas. But no explanation fully fit. This uncertainty sparked a firestorm of debate. Could Oumuamua be something even more extraordinary? Harvard astronomer Avi Loeb famously raised the possibility that it might be artificial, perhaps a fragment of alien technology like a light sail propelled by solar radiation. While most scientists lean toward natural explanations, the mere fact that such ideas entered the conversation shows how baffling this object truly was. The truth is, we may never know for sure. Oumuamua is now beyond the reach of our telescopes, speeding into the void, its secret still intact, yet its legacy is undeniable. Oumuamua shattered assumptions about what lurks between the stars, proving interstellar visitors could drift into our cosmic backyard. Since then, astronomers have spotted a second interstellar object, comet Borisov, but none as enigmatic as our first celestial scout. Oumuamua forced us to rethink how such objects form, how many might be out there, and what they could teach us about distant star systems. It's a humbling reminder that the universe is full of surprises, and sometimes the most profound discoveries arrive unannounced, streaking through the darkness just out of reach. Deep in the cosmic void, beyond the familiar constellations and swirling arms of our Milky Way, something colossal is pulling entire galaxies toward it. An invisible force so powerful that it defies conventional explanation. Astronomers call it the Great Attractor, a gravitational anomaly located roughly 250 million light-years away in the direction of the Centaurus and Norma constellations. But here's the catch: we can't see it directly. This mysterious region lies obscured behind the dense disk of our own galaxy, where interstellar dust and stars block our view, leaving scientists to piece together clues like detectives solving a cosmic crime. The first hints of this enigma emerged in the 1970s when astronomers noticed something peculiar. Our local group of galaxies, including the Milky Way, wasn't just drifting randomly through space. Everything was flowing toward a single point, as if caught in a river of gravity. The scale was staggering. Galaxies across hundreds of millions of light-years were moving in unison, their paths converging toward this hidden titan. The Great Attractor's pull is so immense that it overrides even the expansion of the universe in our corner of the cosmos. But what could possibly exert such a force? One leading theory points to an unimaginably massive concentration of matter, perhaps a supercluster of galaxies, each containing billions of stars, all clumped together in a gravitational knot. The Norma cluster, a dense gathering of galaxies near the suspected epicenter, might be part of the answer, but calculations suggest even this isn't enough to explain the full strength of the attraction. Some researchers propose an even larger structure lurking behind it, like the Shapley supercluster, the most massive known assembly of galaxies in our cosmic neighborhood. Others speculate about exotic possibilities, dark matter anomalies, or cosmic flows from the early universe sculpting the paths of galaxies like invisible hands. Observing the Great Attractor is like trying to study a shadow puppet show through a thick curtain. Traditional optical telescopes struggle to penetrate the Milky Way's zone of avoidance, a dusty region where visible light is absorbed. But astronomers have workarounds. Infrared and radio telescopes like NASA WISE and the Parkes Observatory peer through the cosmic fog, revealing hidden galaxies and mapping the gravitational tug-of-war. Each new observation adds another piece to the puzzle, but the full picture remains frustratingly out of reach. What makes the Great Attractor so fascinating isn't just its mystery, it's what it teaches us about the universe's grand structure. This isn't just a local oddity, it's a reminder that galaxies aren't scattered randomly but are part of an intricate web, shaped by gravity on scales we're only beginning to comprehend. The Great Attractor could be a single thread in an even larger tapestry, hinting at forces and structures beyond our current maps of the cosmos. So while we may never get a clear view of this gravitational giant, its influence is undeniable. It's a cosmic landmark, a reminder that even in the vast emptiness of space, nothing moves in isolation. Every galaxy, every star, even our own Milky Way, is part of a dance choreographed by forces we're still learning to see, a dance where the music is the silent pull of gravity, and the steps are written in the language of the universe itself. If the Great Attractor seems mysterious, wait until you hear about dark flow, an even more unsettling cosmic enigma. Imagine countless galaxy clusters, each containing hundreds of billions of stars, drifting in the same direction like leaves caught in a hidden current. This isn't just random motion. These galaxies are being pulled toward something immense, something beyond the edge of the observable universe, something we can't see, detect, or even fully comprehend. The discovery came when astronomers studied the cosmic microwave background, the faint afterglow of the Big Bang. By analyzing subtle temperature shifts in this primordial light, they noticed something bizarre. Huge clusters of galaxies were moving at astonishing speeds, all toward a single point in space near the constellation Centaurus. But here's what defies logic. This motion can't be explained by any known mass in our universe. The sheer scale of this movement suggests an unfathomable gravitational source lurking outside our cosmic horizon, tugging on everything like a magnet hidden behind a curtain. Theories about dark flow range from the mind-bending to the outright revolutionary. Some physicists suggest it could be evidence of a neighboring universe, a parallel cosmos with its own gravity, exerting influence on ours like a shadow we can't see. Others propose exotic explanations like cosmic defects left over from the birth of the universe, or even modifications to Einstein's theory of gravity itself. But the most startling idea, that dark flow might be the first tangible hint of the multiverse, a reality where our universe is just one bubble in an infinite foam of others. Of course, skepticism exists. Critics argue that measurement errors or unknown local forces could mimic dark flow's effects. Yet multiple studies, including data from NASA, a Wilkinson microwave anisotropy probe, and the Planck satellite, continue to detect this eerie motion. The clusters aren't just drifting, they're racing at speeds exceeding 1,000 kilometers per second, far faster than the universe's expansion should allow. What makes dark flow so haunting is what it implies about the limits of our knowledge. The observable universe stretches 93 billion light-years across, but dark flow hints that there's something beyond, a realm of influence we'll never directly observe. It's as if we're fish in a pond, suddenly noticing the water tilting toward a waterfall we can't see. Whether it's another universe, undiscovered physics, or something even stranger, dark flow forces us to confront a humbling truth. The cosmos we think we know might just be a tiny corner of something infinitely grander and more mysterious than we ever dared imagine. Stars aren't supposed to cheat death when they explode in supernova. That's usually the final act, but the cosmos loves breaking rules. Enter zombie stars, the celestial oddballs that somehow survive their own destruction, defying every textbook on stellar life cycles. Among the most baffling are Type IX supernova, cosmic explosions so underwhelming they're dubbed mini-supernova, leaving behind not total annihilation but a scarred, half-dead star that keeps on shining. Here's how it works. In a typical Type Ia supernova, a white dwarf, the dense core of a dead star siphons material from a companion until it crosses a critical mass threshold, detonating in a thermonuclear blast so bright it outshines entire galaxies. Nothing remains, but Type IX events are different. These explosions are fainter, slower, and strangely messy. Instead of vaporizing the white dwarf completely, they leave behind a mangled remnant, a grotesque, partially destroyed version of itself still clinging to existence. Picture a firework that fizzles halfway through, leaving a smoldering husk behind. What causes these failed explosions? One theory suggests the white dwarf doesn't ignite uniformly. Instead of a clean, symmetrical detonation, the blast might be lopsided, ejecting some material while the core survives. Another idea proposes that the star's composition, perhaps a mix of helium and carbon, triggers a weaker reaction. But the real shocker, some zombie stars might even reignite afterward, continuing to burn for years like cosmic phoenixes. Why should we care? These stellar survivors are rewriting the story of how stars die. They challenge the assumption that supernovae are always final, proving that some stars can endure even their most violent tantrums. And there's a practical twist because Type Ia supernovae are used as standard candles to measure cosmic distances. Zombie stars could be skewing our calculations of the universe's expansion. If some supernovae are secretly weaker, astronomers might need to recalibrate their tools. Then there's the bigger philosophical punch. Zombie stars remind us that the universe is far stranger than our models predict. For every rule we think is ironclad, there's a celestial rebel out there bending it. Whether it's lopsided explosions, exotic chemistry, or some undiscovered physics, these undead stars force us to ask, what else don't we know about the chaotic, beautiful chaos of stellar death? One thing's certain, while zombie stars might sound like science fiction, they're very real, and their existence is a humbling lesson. Even in destruction, the cosmos finds ways to surprise us, leaving behind riddles wrapped in the flickering light of stars that refuse to die. Rising like titanic ghosts from the heart of our galaxy, the Fermi bubbles defy logic. Two colossal structures of scorching gas and gamma radiation, each stretching 25,000 light-years into space. That's half the width of the Milky Way itself, towering above and below the galactic plane like a cosmic hourglass. Discovered in 2010 by NASA's Fermi Gamma Ray Space Telescope, these bubbles glow with the energy of 100,000 exploding stars, yet their origins remain one of the most heated debates in astrophysics. At first glance, the culprit seems obvious: the supermassive black hole at our galaxy's center, Sagittarius, a star. When black holes feed, they belch out jets of high-energy particles, and a past feeding frenzy could have inflated these bubbles like cosmic balloons. But here's the twist: the bubble's edges are razor-sharp, too crisp for a slow, steady process. This suggests something far more violent, a single cataclysmic event, perhaps a black hole burp, lasting mere millions of years, a blink in cosmic time. Or maybe it wasn't the black hole at all. Some models point to an ancient starburst, a frenzy of star formation so intense that supernova explosions piled up, shockwaves rippling outward to carve these immense structures. Then there's the mystery of their timing. The bubbles are relatively young by galactic standards, just a few million years old, meaning whatever created them might have happened while early humans were already walking the Earth. But with no written records of the galactic center's tantrums, we're left reconstructing the event from forensic clues. The bubble's gamma rays hint at particles accelerated to near light speed, while X-ray observations reveal their hollow interiors lined with turbulent magnetic fields. It's as if we're studying the aftermath of a bomb blast, trying to guess the size of the explosion from the shape of the crater. What makes the Fermi bubbles so mesmerizing isn't just their scale, it's how they force us to rethink galactic ecosystems. We used to imagine the Milky Way as a relatively quiet neighborhood with occasional fireworks, but these bubbles suggest our galaxy has a violent temper, capable of eruptions that reshape its very atmosphere. Even now, they're not static, they're fizzing with energy, their particles colliding to produce the very gamma rays that revealed them. And perhaps most intriguingly, they're not alone. Similar structures have been spotted in other galaxies, hinting that this might be a universal phase galaxies go through, a cosmic adolescence marked by explosive growing pains. The deeper we look, the more questions arise. Why do the bubbles' emissions vary so dramatically at different energies? Could dark matter annihilation, a theoretical process where invisible particles collide, play a role in powering them? Or is there some entirely unknown mechanism at work, something beyond our current physics? Every new telescope, from the upcoming Cherenkov telescope array to advanced radio observatories, brings us closer to answers. But for now, the Fermi bubbles stand as a humbling reminder. Even in our own galactic backyard, the universe keeps its most explosive secrets hidden in plain sight. Most cosmic structures swirl and spiral in chaotic splendor, but the Red Rectangle Nebula defies the norm with near-perfect symmetry, a glowing geometric masterpiece floating 2,300 light-years away in the constellation Monoceros. At first glance, it looks like an interstellar stop sign, two luminous cones of gas stacked base to base, forming an eerie, almost artificial rectangle. This isn't some trick of perspective. The nebula's crisp X-shape and ladder like rungs of glowing material are real, sculpted by forces far stranger than your average stellar winds. The secret lies at its heart, a pair of aging binary stars locked in a cosmic waltz. The primary star, HD 44179, is a post-red giant shedding its outer layers, while its smaller companion whips around it every 10 months. This dance creates opposing jets of gas, ejected perpendicular to their orbital plane like spinning garden sprinklers. As the expelled material crashes into older debris, it forms those iconic cone shapes, while dust scatters starlight into the nebula's haunting red glow. But the vibrancy isn't just aesthetic. The red hue comes from a rare form of carbon molecules called polycyclic aromatic hydrocarbons, cosmic soot illuminated by ultraviolet starlight. What makes the Red Rectangle truly special isn't just its symmetry, it's a preview of our own sun's fate. In 5 billion years, as our star dies, it too may puff away its outer layers, creating a planetary nebula. But unlike the chaotic bubbles of the Crab Nebula or the delicate rings of the helix, HD 44179's binary partnership ensures an orderly exit. The companion star's gravity funnels debris into precise cones, proving that even in death, celestial mechanics can carve art from chaos. Yet this masterpiece is temporary. The nebula's gas is expanding at nearly 30 kilometers per second, thinning as it disperses into interstellar space. Within a few thousand years, a cosmic eye blink, its vivid geometry will fade, leaving only a cooling white dwarf behind. For now, though, the Red Rectangle stands as one of nature's most precise creations, a fleeting reminder that the universe sometimes trades chaos for perfect, if fleeting, order. Imagine a world where the ground beneath your feet isn't rock or ice but solid diamond, glittering under the light of a dead star. That's PSRJ 1719-1438b, a planet so dense and exotic it defies everything we know about celestial formation. Discovered in 2011, this bizarre world orbits a pulsar, a rapidly spinning neutron star every 2 hours and 10 minutes, trapped in a gravitational dance so tight it would vaporize most planets. But here's the real shocker. Scientists believe this planet isn't just rich in carbon, it is carbon crystallized into a diamond larger than Earth. The story of how this cosmic jewel came to exist reads like a celestial horror tale. Billions of years ago, the pulsar it orbits wasn't always a corpse. It began as a massive star with a binary companion, a white dwarf made mostly of carbon and oxygen. When the massive star went supernova, it collapsed into a pulsar, but its gravitational pull was so intense it began cannibalizing its neighbor. Over eons, the pulsar stripped away the white dwarf's outer layers, leaving behind a corpse so compressed that its carbon core, under unimaginable pressure, crystallized into a planet-sized diamond. Today, what remains is a relic of stellar vampirism, a world whose very composition would make Earth's rarest gems look like pebbles. What makes this planet truly mind-bending is its density. Calculations suggest it's nearly 20 times denser than Jupiter, yet only slightly more massive than Earth. That means it's packed so tightly that a teaspoon of its material would weigh thousands of tons on Earth. The conditions there are beyond extreme surface temperatures soaring into the thousands of degrees, bathed in deadly radiation from its pulsar host. Forget mining this diamond. any probe that got close would be shredded by gravitational tides or fried by gamma-ray bursts. But the real intrigue isn't just about the spectacle. PSR J1719-1438b challenges our understanding of planet formation. Most planets form from the dusty leftovers of star birth, but this one was forged from destruction, a phoenix risen from a star's ashes. It's a reminder that the universe doesn't just build worlds, it transforms them, twisting the remains of dead stars into something entirely new. Could there be more diamond planets out there? Possibly. Pulsars are notorious for their violent pasts, and if this one could create such a jewel, others might have too. The discovery forces astronomers to reconsider the diversity of exoplanets, not just rocky or gaseous, but crystalline, metallic, or even stranger. Each find like this peels back another layer of cosmic possibility, proving that the universe's creativity knows no bounds. And while we'll never set foot on this glittering gravestone of a star, its existence alone is a dazzling testament to the alchemy of the cosmos. Deep in the heart of the Virgo cluster, a cosmic titan rules with gravitational tyranny, Messier 87, a supergiant elliptical galaxy with an appetite so voracious it shreds and consumes its smaller neighbors. This isn't some abstract galactic process. Astronomers can actually see the aftermath of its feasts. Stretched across the void like ghostly ribbons, vast streams of stars, remnants of devoured galaxies, swirl around M87's core, their trajectories betraying a violent past. These stellar rivers, some spanning thousands of light years, are the smoking gun of a galaxy that never stops feeding. The scale of destruction is almost poetic. When a smaller galaxy wanders too close, M87's immense gravity stretches it like cosmic taffy, pulling stars away in long, luminous tendrils. Over billions of years, these orphaned stars settle into chaotic orbits, forming the haunting shell structures and streams that now encircle the galaxy. But M87's most infamous feature lies at its heart, the first black hole ever directly imaged by humanity. In 2019, the Event Horizon Telescope unveiled a glowing ring of fire, the shadow of a supermassive black hole weighing 6.5 billion times our sun's mass. This monster doesn't just lurk silently, it launches a relativistic jet of plasma over 5,000 light-years into space, a sizzling beam of particles moving at nearly the speed of light. What connects these phenomena? Everything. The black hole's jet, fueled by infalling matter from its accretion disk, is a byproduct of the same insatiable hunger that drives the galaxy's cannibalism. As M87 consumes gas, stars, and even whole dwarf galaxies, some material spirals toward the black hole, superheating until it's blasted back out as that terrifying jet. It's a self-sustaining cycle. The more the galaxy eats, the more powerful the jet becomes, which in turn disrupts nearby galaxies, making them easier prey. But here's the twist: M87 isn't just a destroyer. Those shredded stellar streams are cosmic gold mines for astronomers. By mapping their motions, scientists can reconstruct the galaxy's meal history, like paleontologists piecing together fossils. Some streams still carry the chemical signatures of their original galaxies, offering clues about the universe's early structure. Even the jet, for all its fury, plays a role in galactic ecology. Its energy mixes interstellar gas, potentially sparking new star formation in unexpected places. This isn't just a tale of one galaxy's dominance. M87 is a preview of our own Milky Way's fate. Billions of years from now, when we collide with Andromeda, the resulting Milkomda galaxy may resemble this cosmic Goliath, a chaotic blend of cannibalized stars with a titanic black hole at its core. For now, M87 stands as both a warning and a wonder, proving that even in the vastness of space, the cycle of creation and destruction is never ending and never less than spectacular. Between the constellations of Bootes and Draco lies one of the universe's most unsettling mysteries, a yawning chasm of nothingness so vast it could swallow thousands of galaxies without a trace. Astronomers call it the Boots Void, a spherical abyss spanning 330 million light-years where space itself seems to have forgotten how to make galaxies. If you were to fly through this void at the speed of light, you'd travel for hundreds of millions of years without seeing more than a handful of isolated stars. For context, our Milky Way's neighborhood has thousands of galaxies in a space that size, but here, less than 60 have been found, leaving 99.9% of the void's volume eerily empty. What makes the Boots Void so unnerving isn't just its emptiness, it's how blatantly it defies our understanding of cosmic structure. After the Big Bang, matter wasn't spread evenly. It clumped into filaments and walls, creating a cosmic web where galaxies gather like cities along invisible highways. Voids exist in this web, but they're usually small, 50 to 100 million light-years across. The Boots Void, however, is an outlier so extreme it's been nicknamed the Great Nothing. Finding something this empty is like stumbling upon a desert the size of the Pacific Ocean. It shouldn't exist under known physics, so how did it form? One leading theory suggests smaller voids merged over billions of years, like soap bubbles combining into one giant cavity. But even that struggles to explain the Boots Void's staggering scale. More radical ideas flirt with cosmology's edges. Could it be the imprint of a collision with another universe? Some models of multiverse theory predict that neighboring universes might leave scars where they brushed against ours, regions where matter was scooped out like a spoonful of cosmic soup. Others propose exotic physics, like quantum fluctuations frozen in during the universe's infancy, creating accidental deserts in the fabric of space. Yet the void isn't completely barren. Those 60-odd galaxies inside it huddle together in a small cluster, like survivors on a lifeboat adrift in an endless ocean. Intriguingly, many of these galaxies show signs of extreme youth, bursts of star formation hinting at turbulent pasts. Were they refugees pulled into the void by some ancient gravitational tug of war? Or did they form in isolation, starved of the intergalactic gas that fuels most galaxies? Each one is a puzzle, their very existence challenging assumptions about how galaxies evolve in the universe's emptiest corners. For astronomers, the Boots Void is more than a curiosity. It's a stress test for our models of the cosmos. If voids this large can form naturally, it might mean we've underestimated how chaotic the early universe truly was. If they can't, it could signal gaps in our understanding of gravity, dark energy, or even the nature of space itself. Every new telescope survey scans this desert, searching for faint galaxies that might rewrite its story. But for now, the Great Nothing remains a haunting reminder. Sometimes, the universe's most profound statements are whispered not in light but in absence. For centuries, astronomers have reported eerie flashes of light dancing across the moon's surface, sudden glows, colored hazes, even misty plumes rising from craters where nothing should move. These aren't tricks of the eye, they're transient lunar phenomena, or TLP, unpredictable bursts of activity on a world we thought was geologically dead. Some observations date back to the 12th century when monks chronicled fire erupting near the moon's crescent. Modern telescopes have captured more: brief crimson flares in Aristarchus crater, shimmering violet clouds over Pluto's plains, and ghostly tendrils of light stretching miles above the surface. The strangest part, despite decades of study, no one can say for sure what causes them. One leading theory points to trapped gas. The moon's crust might still hold pockets of radioactive elements like radon or helium from its volcanic past. As these decay, they could release bursts of gas through cracks, sending dust skyward in glittering plumes when sunlight hits. Others propose electrostatic levitation, a bizarre effect where ultraviolet light from the sun charges lunar dust, causing it to float like a mist above the surface. Then there's the more explosive idea: micrometeorite impacts. Tiny space rocks striking the moon at thousands of miles per hour could vaporize on contact, creating momentary flashes of molten material. The Apollo missions should have solved the mystery. Astronauts carried seismometers and gas detectors, even aiming cameras at hotspots where TLPs frequent. Yet their data only deepened the puzzle. Apollo 17's instruments recorded a sudden temperature spike in Taurus Littrow Valley. No quake, no impact, just a patch of ground inexplicably heating up. Orbiting probes saw similar anomalies, like Japan's Kaguya spotting a strange glow near the crater Giordano Bruno that vanished within hours. The moon, it seems, is still whispering secrets. Perhaps the most haunting possibility is that TLPs aren't one phenomenon but many. The flashes could be gas, the hazes dust, the plumes something else entirely, a cosmic cocktail of mysteries. Future missions like NASA Artemis rovers might finally crack the case by sampling lunar soil in real time. Until then, these fleeting lights remain a reminder that even our closest celestial neighbor keeps surprises hidden in its shadowed valleys. A silent world that occasionally, brilliantly, refuses to stay silent at all. Astronomers expected the early universe to be a chaotic nursery, a place where infant galaxies clashed and swirled in turbulent, misshapen blobs, slowly settling into the elegant spirals we see today. But the cosmos, as always, had other plans. In recent years, telescopes peering back over 12 billion years have spotted something unbelievable: fully formed disk galaxies, spinning with the grace of mature cosmic whirlpools at a time when theory says they shouldn't exist. The most famous of these cosmic rule breakers, the Wolf Disk, a colossal, rotating galaxy spotted when the universe was just 1.5 billion years old, barely 10% of its current age. This discovery sent shockwaves through astrophysics. Current models suggest disk galaxies like our Milky Way take billions of years to form. Gravity must slowly draw gas inward, allowing it to cool and flatten into a spinning disk, a process that shouldn't have had enough time in the universe's fiery youth. Yet the Wolf Disk defies this timeline. Observations from the Atacama Large Millimeter Array reveal a crisp, rotating structure over 100,000 light-years wide, brimming with cold gas and stars. It's as if someone fast-forwarded cosmic evolution, skipping straight to the finished product. So how did this happen? One radical theory suggests early galaxies didn't need slow, violent mergers to take shape. Instead, streams of cold gas might have flowed directly into the Wolf Disk, cooling rapidly and settling into an orderly rotation without the usual growing pains. Another idea proposes that dark matter, the invisible scaffolding of the cosmos, organized itself into smoother, more stable halos back then, providing a calmer environment for disks to form. But both explanations raise new questions. If cold gas flows were so efficient, why aren't all early galaxies disks? And why do later galaxies seem to form through messier processes? The implications are staggering. If galaxies like the Wolf Disk were common in the early universe, we might need to rewrite the entire story of cosmic structure. Textbooks describe galaxy formation as hierarchical small pieces crashing together to build larger ones over eons. But the Wolf Disk suggests some galaxies skip the construction phase entirely, emerging fully formed like Athena from Zeus's forehead. This doesn't just tweak the timeline, it challenges our understanding of how gravity, gas, and dark matter interact on the grandest scales. Even more tantalizing, the Wolf Disk isn't alone. Other impossibly mature galaxies keep turning up in deep field surveys, each one a thorn in the side of conventional models. Some show intricate spiral arms, while others have massive, stable bulges, all features thought to require ages to develop. Every discovery like this forces astronomers to ask, did we underestimate the universe's ability to self-organize? Or is there some lost chapter in the physics of galaxy formation, a process we haven't even imagined yet? For now, the Wolf Disk stands as both a marvel and a provocation, a glimpse of a universe that might be far more efficient, far more elegant than we ever dreamed. It's a reminder that the cosmos doesn't just follow our rules, it writes its own. And sometimes the most profound discoveries come from the places we least expect, where the impossible becomes real. For centuries, dark matter has been the invisible glue holding galaxies together, an unseen force so fundamental that its presence defines the very structure of the cosmos. That's what made the discovery of NGC 1052DF2 so earth-shattering. This ghostly galaxy, floating 65 million light-years away in the constellation Cetus, isn't just unusual, it appears to lack dark matter entirely. Imagine finding a car without an engine or a tree without roots. That's the level of cosmic contradiction we're dealing with here. First spotted in 2018, DF2 is what astronomers call an ultra-diffuse galaxy, a wispy, almost transparent collection of stars so thinly spread that you could peer straight through it like cosmic lace. But while most galaxies of this type are stuffed with dark matter, DF2 stars move sluggishly, their orbits betraying a shocking lack of the invisible mass that should be tugging on them. Calculations suggest this galaxy contains at most 1/400th the dark matter expected for its size. To put that in perspective, if the Milky Way were a city, dark matter would be its subway system, hidden but essential for keeping everything running. DF2, by contrast, is a city built on air. The implications are staggering. For decades, dark matter wasn't just part of galaxy formation theory, it was the theory. The prevailing model says galaxies form when dark matter clumps into halos, their gravity drawing in gas and stars like moths to a flame. Without dark matter, according to textbooks, galaxies like ours shouldn't exist. Yet here's DF2 flaunting its defiance. Some researchers initially questioned the measurements. Maybe we were misreading the distances or the star motions. But follow-up studies, including meticulous Hubble Space Telescope observations, only cemented the anomaly. DF2 isn't a measurement error, it's a cosmic rebel. So how did this phantom galaxy come to be? One provocative theory suggests it might be the aftermath of a high-speed collision. Picture two galaxies slamming together at millions of miles per hour. Their dark matter, which interacts weakly, keeps sailing onward like ghosts passing through walls, while the visible stars get left behind in the wreckage. Another idea posits that DF2 was born in a freak cosmic bubble, a region where dark matter was inexplicably scarce from the start. There's even a wilder possibility that dark matter isn't a single substance but multiple types, some of which might behave in ways we haven't yet detected. The plot thickened with the discovery of a second dark matter-deficient galaxy, NGC 1052DF4, lurking nearby. Together, they hint at a family of oddballs, perhaps shaped by their violent neighborhood near the massive elliptical galaxy NGC 1052. But here's the twist. If dark matter isn't always the galactic architect we thought, what other forces could be building these structures? Some researchers point to tidal interactions, gravitational theft where larger galaxies strip smaller ones of their dark matter over eons. Others wonder if we're seeing the handiwork of alternative gravity theories where dark matter isn't needed at all. What makes DF2 so electrifying isn't just the mystery, it's the way it forces us to question cosmic certainties. For every rule we've etched in textbooks, the universe seems to keep an exception in its pocket. Whether DF2 is a cosmic fluke, a sign of undiscovered physics, or a clue to dark matter's true nature, one thing's clear: this phantom galaxy isn't just challenging our models. It's rewriting the rules of the game. Most black holes loom in the darkness like cosmic predators, monstrous voids with gravity so strong they devour stars whole. But tucked away in the constellation Monoceros, barely 1,500 light-years from Earth, lies a cosmic oddity that redefines what a black hole can be. Nicknamed the Unicorn, this mysterious object weighs just 3 times our Sun's mass, making it one of the smallest black holes ever discovered, and by far the closest to Earth. Yet here's what's truly bizarre. We wouldn't even know it existed if not for the tortured dance of a nearby red giant star, its outer layers stretched into a teardrop shape by an invisible companion's pull. The discovery, announced in 2021, was a masterclass in cosmic detective work. Astronomers weren't hunting for black holes at all. They were studying the star V723 Monocerotes, a pulsating red giant whose light rhythmically dimmed and brightened. But something was off. The star's motion betrayed an unseen partner yanking on it with surprising force, and its light curves revealed telltale distortions, as if an invisible hand were kneading the star like dough. After ruling out planets, white dwarfs, and neutron stars, only one explanation fit: a black hole so lightweight it defied expectations. Why is the unicorn so special? Most known black holes fall into two categories: stellar mass black holes, born from collapsing stars at least 20 times heavier than our Sun, or supermassive behemoths lurking in galactic cores. The unicorn bridges an elusive gap. Theory predicted these low-mass black holes should exist, remnants of stars too light to form typical black holes yet too heavy to become neutron stars. But finding them is like spotting a needle in a galaxy-sized haystack. Unlike their larger cousins, tiny black holes don't voraciously consume enough material to emit detectable X-rays. They're cosmic phantoms, revealing themselves only through gravitational sleight of hand. That's where the unicorn's tortured star comes in. As the red giant orbits the black hole every 60 days, its outer layers get pulled into a banana-shaped distortion, a phenomenon called tidal disruption. By measuring the star's twisted light and wobbling motion, astronomers could reconstruct the black hole's mass and orbit with stunning precision. It's like deducing the size and speed of a hidden wrecking ball by watching how it bends a street lamp. But the unicorn isn't just a curiosity, it's a laboratory for testing gravity's limits. Einstein's theory of general relativity has been proven repeatedly in strong gravitational fields, like those around supermassive black holes. But the unicorn's gentle tug offers a rare chance to study relativity in a milder regime. Does gravity behave differently around these featherweight voids? Could they harbor clues about exotic states of matter or even new physics? Every shudder of the red giant's light might hold answers. The hunt is now on for more of these cosmic unicorns. If they're common, it could rewrite stellar evolution models, suggesting far more stars collapse into black holes than we thought. If they're rare, their scarcity might hint at gaps in our understanding of supernova mechanics. Either way, the unicorn reminds us that even our cosmic backyard hides revelations quietly warping the light of a lonely star, whispering secrets about the universe's most enigmatic shadows. Imagine a planet with no sunrise, no sunset, just endless night as it drifts through the freezing void between stars, untethered to any sun. These aren't science fiction. They're rogue planets, cosmic nomads flung from their home systems by gravitational chaos or born alone in the darkness of interstellar space. Unlike Earth, which basks in the warmth of our sun, rogue planets wander the galaxy in perpetual exile, their surfaces frozen to temperatures near absolute zero. Yet despite their loneliness, some of these worlds might harbor secrets that could rewrite the rules of where life can exist. Detecting these drifters is like finding a single candle in a continent-sized blackout. Without a star's light to illuminate them, rogue planets are nearly invisible but not entirely. Astronomers use two ingenious methods to spot them. First, microlensing. When a rogue planet passes in front of a distant star, its gravity bends and magnifies the star's light like a cosmic magnifying glass, creating a telltale flare that betrays its presence. Second, some rogue planets, especially younger ones, still glow faintly with the residual heat of their formation, letting infrared telescopes pick up their dim warmth against the colder backdrop of space. But here's where the story gets surreal. Some rogue planets might not be the frozen wastelands we assumed. Take SIMP J01365663 plus 0943313. a rogue world 6 times the mass of Jupiter discovered in 2016. This planet doesn't just drift, it crackles with auroras. Shimmering light shows stronger than anything on Earth. Unlike our auroras, which come from solar particles colliding with our magnetic field, this planet's displays might stem from a magnetic dance with its own moons or even an internal dynamo of exotic materials. It's a haunting reminder that even in exile, these worlds can be dynamic, even beautiful. Even more tantalizing is the possibility of life. Rogue planets with thick hydrogen atmospheres could trap enough geothermal heat to maintain subsurface oceans, liquid water buried beneath miles of ice, kept warm by radioactive decay or tidal flexing from orbiting moons. These hidden seas might resemble Earth's deep ocean hydrothermal vents, where life thrives without sunlight in utter darkness. If microbes exist there, they'd be part of an ecosystem entirely cut off from the energy of stars, proof that life might flourish in the most unexpected corners of the cosmos. Could such worlds be more common than we think? Some estimates suggest there might be billions of rogue planets in our galaxy alone, outnumbering stars by a significant margin. If even a fraction have the right conditions, the galaxy could be teeming with hidden biospheres, adrift between the stars. Future missions like NASA's and Nancy Grace Roman Space Telescope aim to hunt these nomads in earnest, potentially uncovering a whole new class of habitable worlds, ones that redefine what it means to be a planet. Rogue planets challenge our Earth-centric view of habitability. They force us to ask, does life need a sun? Or can it spark in the eternal night, sustained by the slow heartbeat of a planet's internal heat? Whether these drifters are barren ice balls or veiled oases, one thing's certain: the universe's imagination is wilder than ours, crafting possibilities where we once saw only emptiness. And somewhere out there, in the endless dark, a rogue planet might be carrying its secrets silently through the void, waiting to be found. In the vast expanse of space, where the remnants of dead stars paint the cosmos with eerie beauty, few structures are as hauntingly mesmerizing as the so-called cosmic hand, a pulsar wind nebula stretching 150 light-years across, its ghostly fingers reaching through the darkness like a skeletal grasp frozen in X-ray light. This celestial phantom, officially named MSH 1552, was born from the violent death of a massive star whose core collapsed into a pulsar, a rapidly spinning neutron star no larger than a city, but wielding a magnetic field so intense it bends reality itself. What makes the cosmic hand so breathtaking isn't just its shape, but the forces behind its creation. The pulsar at its heart spins 7 times per second, firing jets of charged particles at nearly light speed. These particles collide with debris from the ancient supernova, causing them to glow in high-energy X-rays. But the real magic happens when the pulsar's magnetic field, trillions of times stronger than Earth's, sculpts these particles into delicate, finger-like tendrils. Imagine a cosmic potter spinning clay, except here the clay is superheated plasma, and the potter's wheel is a magnetic whirlpool capable of twisting space-time. NASA Chandra X-ray Observatory captured this spectacle in stunning detail, revealing how the pulsar's winds carve intricate loops and ripples into the nebula's structure. The fingers aren't static, they writhe and shift over centuries, responding to the pulsar's furious energy output. Some regions glow brighter where particles are accelerated to extreme energies, creating knuckles of X-ray light, while others fade into wispy trails like smoke dissipating from a candle. It's a dynamic, ever-changing masterpiece painted in radiation. But the cosmic hand isn't just a cosmic oddity, it's a laboratory for understanding how stellar corpses shape their surroundings. By studying how the particles flow along the magnetic field lines, astronomers can map the invisible forces at work, much like iron filings revealing the shape of a bar magnet's influence. The pulsar's energy injects new life into the nebula, heating gas, triggering shock waves, and even potentially birthing new molecules in the turbulent chaos. Here's the spine-tingling part. This structure is a preview of our own solar system's fate. Billions of years from now, when the sun dies, its core could also collapse into a pulsar, wreathed in a glowing nebula of its own making. Whether it'll sculpt something as eerily beautiful as the cosmic hand remains to be seen, but it's a humbling reminder that even in death, stars leave legacies more vivid than we dare imagine. Tucked away in the vast cosmic tapestry, there's a class of galaxies so peculiar they look like scattered emeralds against the black velvet of space, green pea galaxies. These tiny, vibrant structures, some no larger than a tenth of the Milky Way, defy expectations by glowing with an intense green hue, a rare sight in the cosmos. Discovered in 2009 by citizen scientists sifting through data from the Sloan Digital Sky Survey, these galaxies immediately stood out not just for their color, but for their astonishing rates of star formation, churning out new stars up to 100 times faster than our own galaxy. What makes them green? The answer lies in their frenetic energy. Green peas are packed with ionized oxygen, a byproduct of their extreme stellar nurseries. When young, massive stars, often dozens of times hotter than our sun, blast their surroundings with ultraviolet radiation, they excite oxygen atoms in the surrounding gas clouds. These atoms then emit a specific wavelength of green light, painting the entire galaxy in a surreal, verdant glow. It's like a neon sign in the void, powered by the raw energy of stellar birth. But the real magic of these galaxies isn't just their color. It's what they reveal about the universe's infancy. Green peas are cosmic time capsules, mirroring conditions thought to dominate the early universe just a few billion years after the Big Bang. Back then, space was a fog of neutral hydrogen, opaque to light. Then something happened, a process called reionization, where the first stars and galaxies flooded the cosmos with enough radiation to strip electrons from hydrogen atoms, turning the universe transparent. The exact sources of this cosmic dawn remain a mystery, but green peas offer a clue. Their intense radiation and compact size make them perfect analogs for those pioneer galaxies, suggesting even modest galaxies could have played an outsized role in lighting up the cosmos. Here's where it gets even more fascinating. In 2021, astronomers studying a green pea galaxy named J0925+1403 found it leaking ultraviolet photons into intergalactic space, exactly the kind of energy needed for reionization. This discovery hinted that similar galaxies, billions of years ago, might have been the universe's first lanterns, their collective glow piercing the primordial darkness. It's a humbling thought. These unassuming green specks, barely noticed at first, could hold the key to one of cosmology's biggest questions. Yet green peas aren't just relics, they're also cosmic oddballs in their own right. Some exhibit bizarre chemical compositions, with surprisingly low levels of heavier elements like iron and carbon, traces usually left by generations of stars. This suggests they're relatively pristine, their gas not yet polluted by repeated stellar cycles. Others show signs of violent interactions, their shapes distorted by collisions or internal turbulence, as if they're tearing themselves apart with the sheer intensity of their star-forming frenzy. The more we study them, the more questions arise. Why do some green peas flicker out after just a few million years, while others sustain their star-making frenzy? Could their unique environments foster unusual stellar populations, like supermassive stars we've never seen? And most tantalizingly, if they're such close cousins to the universe's first galaxies, could they also host some of the earliest viable conditions for life? Green pea galaxies remind us that the universe's grandest narratives often hide in the smallest corners. They're proof that brilliance doesn't require size, just the right conditions, a spark of energy, and perhaps a touch of cosmic serendipity. And as telescopes like James Webb peer deeper into the past, these tiny green miracles might just lead us to the next great breakthrough in our understanding of how light first triumphed over darkness. Somewhere in the vast cosmic tapestry, a supermassive black hole is on the run, streaking through intergalactic space at 5 million miles per hour, leaving a glittering trail of newborn stars in its wake. Astronomers first spotted this cosmic fugitive in 2023, a behemoth weighing as much as 20 million suns, ejected from its home galaxy with enough force to escape forever. What could possibly kick a black hole this massive out of its galactic seat of power? The answer lies in a gravitational showdown of epic proportions. When galaxies collide, their central black holes eventually spiral toward each other, locked in a deadly dance. If a third galaxy joins the chaos, the resulting three-body gravitational tug of war can fling one of the black holes outward at unimaginable speeds, like a cosmic slingshot. That's likely what happened here. Hubble Space Telescope images reveal a luminous streak of young, blue stars stretching 200,000 light-years behind the rogue black hole, a trail almost twice the diameter of our Milky Way. These stars shouldn't exist in the lonely void between galaxies, but as the black hole plowed through clouds of gas, its immense gravity compressed the material, triggering star formation in its turbulent wake. It's as if the black hole is gardening the cosmos, planting stars where none should grow. The sheer violence of this ejection defies intuition. Simulations suggest it took the combined gravity of two other supermassive black holes, likely now merged into an even larger monster, to boot this one into the abyss. The energy released in the process would have rippled space-time itself, sending gravitational waves across the universe. Yet what's even stranger is the star trail's structure. Normally, black holes devour gas voraciously, heating it into glowing accretion disks. But this one seems to be moving too fast to feed efficiently, creating a bizarre, one-sided shockwave that condenses gas into stars instead of swallowing it whole. This discovery isn't just a spectacle, it's a paradigm shift. Astronomers once assumed supermassive black holes were anchored forever at galactic centers. Now we've caught one red-handed in a cosmic jailbreak. If this can happen, how many other runaway black holes are drifting unseen through the darkness? Some theories suggest these renegades could be the seeds of rogue galaxies, their stolen gas eventually forming new stars around them in isolation. Others wonder if their star trails might create unexpected oases for life, far from the radiation of crowded galactic cores. The hunt is now on for more of these fugitives. With every new observatory, from the James Webb Space Telescope to next-generation gravitational wave detectors, we're peeling back another layer of black hole behavior. And each revelation, like this speeding giant, forces us to rethink the extremes of cosmic violence, where even the universe's most powerful objects can become exiles, painting the void with stolen starlight. At the edge of the observable universe, where light has traveled nearly 11 billion years to reach us, astronomers found something that shouldn't exist, a trio of quasars bound together in a cosmic dance so tight, it defies everything we know about the early universe. These aren't just any quasars, they're the brightest, most violent objects in existence, each powered by a supermassive black hole feasting on gas at the heart of a young galaxy. Conventional wisdom says such tight-knit groups couldn't have formed when the universe was barely 2 billion years old. Yet there they were, shining defiantly, their existence threatening to rewrite the story of how cosmic structures grow. What makes this trio so impossible? Picture trying to build a skyscraper in a day. The early universe was a place of chaos, where matter was still sorting itself into galaxies and clusters. For three quasars, each requiring a supermassive black hole with billions of times the sun's mass, to form so close together so quickly, they'd need impossibly dense seeds of matter or a shortcut in black hole formation physics we've never imagined. Current simulations struggle to recreate such a configuration without breaking known rules of gravity and cosmic evolution. Yet observations from the Keck Observatory and the Very Large Telescope leave no doubt. this triplet is real, its members separated by less than 100,000 light-years, closer than the distance between the Milky Way and the Magellanic Clouds. The implications ripple far beyond this one anomaly. If quasars can cluster this tightly in the universe's youth, it suggests large-scale structures, filaments, walls, and galaxy clusters might have assembled much faster than models predict. Some theorists propose a radical solution. Perhaps the early universe wasn't as uniform as we think. Tiny knots of extreme density could have collapsed into black holes almost instantly after the Big Bang, skipping the slow growth we observe in later epochs. Others wonder if dark energy or exotic forms of matter played a role, warping space-time in ways that accelerated cosmic evolution in select pockets. Then there's the haunting question of what happened next. Such a dense grouping of quasars would have been a gravitational powder keg. Did they eventually merge into a single, unfathomably massive black hole? Or did their violent radiation blow away surrounding gas, starving future star formation and leaving behind a ghostly void? The answers could reshape our understanding of how the universe's most extreme environments influence galactic evolution. For now, the impossible quasar trio stands as both a revelation and a provocation, a cosmic Edvard Munch scream frozen in time, challenging us to rethink the universe's blueprints. It's a reminder that the cosmos often reserves its greatest surprises not in the familiar present, but in the uncharted depths of the distant past, where the rules we take for granted might not apply at all. Imagine a ring system so vast it makes Saturn's iconic loops look like a child's hula hoop. That's J1407b, an exoplanet 734 light-years away in the constellation Centaurus, where astronomers stumbled upon a set of rings so colossal they stretch nearly 120 million kilometers wide, 200 times the diameter of Saturn's entire ring system. If you swapped Saturn for J1407b in our solar system, its rings would dominate the sky, stretching wider than the distance between Earth and the Sun, casting shadows so deep they'd turn daylight into twilight. The discovery wasn't made by spotting the rings directly, but by watching their shadowy fingerprints in starlight. As the planet orbited its young, sun-like star, astronomers noticed bizarre, irregular dimming, deep eclipses that lasted for weeks with intricate dips and spikes in brightness. Instead of a clean, symmetrical transit like most planets produce, the star's light flickered erratically, as if something with complex structures was passing by. After ruling out starspots and cometary swarms, the only explanation was a gargantuan ring system, its countless bands and gaps blocking starlight like a cosmic Venetian blind. But here's the catch: rings this massive shouldn't exist, at least not for long. Saturn's rings are relatively stable thanks to the gravitational influence of its moons, which shepherd the icy particles into orderly orbits. J1407b's rings, by contrast, are so expansive that their outer edges should have coalesced into moons within a few million years. Yet there they are, frozen in time, defying expectations. One theory suggests the planet is still young, its rings fresh from the chaotic aftermath of its formation, not yet eroded by time or gravity. Another possibility. The rings are being replenished perhaps by the slow destruction of a moon torn apart by tidal forces, its remains feeding the rings like a cosmic conveyor belt. What makes this system even stranger is its scale. If the rings are as dense as Saturn's, they could weigh as much as 40 Earths, enough material to build multiple moons. Yet somehow they persist in this delicate, fleeting state. Some researchers speculate the planet might be a brown dwarf, a failed star rather than a traditional gas giant, its stronger gravity somehow stabilizing the rings. Others wonder if we're witnessing a rare cosmic snapshot, a fleeting moment in a ring system's violent evolution that we just happen to catch before it disappears forever. The real intrigue lies in what these rings could teach us about planetary formation. Most exoplanet detections are just dots of light, but J1407b's rings offer a forensic record of its history. The gaps between the rings might hint at hidden moons, while their composition, likely ice and dust, could reveal the chemistry of its primordial disk. Every flicker of starlight holds clues, and with next-gen telescopes like the James Webb Space Telescope, we might soon decode them. For now, J1407b remains a cosmic paradox, a planet wearing a crown too grand to last, a fleeting masterpiece in a universe that rarely lets beauty linger. Whether it's a youthful prodigy or a celestial miracle, one thing's certain: this isn't just a planet with rings, it's a monument to the universe's capacity for grandeur, even in the face of its own immutable laws. Hidden in the constellation Coma Berenices, drifting 330 million light-years away, lies a cosmic ghost, a galaxy that barely glimmers in the void. Dragonfly 44 isn't just dim, it's almost entirely invisible, a shadowy leviathan built not from stars but from dark matter. If you could hold it side by side with the Milky Way, the difference would be staggering. Our galaxy blazes with hundreds of billions of stars, while Dragonfly 44, despite being roughly the same size, shines with only 1% of that stellar firepower. At first glance, it seems impossible, a galaxy that barely exists yet somehow weighs as much as our own. The reason: this cosmic wraith is 99.99% dark matter, a gravitational skeleton without the luminous flesh we expect. Detecting something this faint required a revolution in telescope design. Traditional instruments missed it entirely until 2015, when astronomers used the Dragonfly telephoto array, a cluster of 48 modified camera lenses designed to catch ultra-faint light. What they found defied logic. The galaxy's stars are so sparse you could fly through it for light years without seeing one, yet their motions betray an immense gravitational presence. Like leaves caught in a whirlpool, these stars orbit at speeds that should fling them into the void unless something invisible, something massive, holds them in place. That something is dark matter, the universe's most enigmatic substance, woven into a galaxy-sized web where light barely lingers. Dragonfly 44's discovery sent shockwaves through astrophysics because it shouldn't exist under standard galaxy formation models. Most galaxies balance dark matter with visible stars, their gravity and light intertwined. But here's a place where the scales tipped wildly, where dark matter dominates so completely it raises unsettling questions. Did this galaxy form differently, its stars snuffed out by some ancient cataclysm? Or is it a pristine relic of the early universe, a place where dark matter clumped without igniting stellar fires? The leading theory suggests it's a failed galaxy, one that amassed a colossal dark matter halo but somehow missed the gas needed to birth stars in abundance. Yet what truly fascinates scientists isn't just its strangeness, it's what Dragonfly 44 implies about the cosmos. If one such galaxy exists, there could be thousands, even millions more, hiding in plain sight. These dark dominions might solve a lingering cosmic mystery, the missing satellites problem. Simulations predict our Milky Way should be surrounded by hundreds of small satellite galaxies, yet we've found only a few dozen. Could the rest be like Dragonfly 44, so dim we've overlooked them? Recent surveys have uncovered other ultra-diffuse galaxies, but none as dark matter, rich as this one, making it a tantalizing outlier. The search for answers continues. Astronomers now scrutinize Dragonfly 44 for traces of globular clusters, dense groups of ancient stars that often orbit galaxies. Surprisingly, it hosts nearly 100, far more than expected for its meager starlight. These clusters might be the galaxy's last survivors, clinging to a dark matter backbone that long ago outlived its stellar glory. Even more intriguing, some researchers propose that dark galaxies could be the universe's factories for rogue planets, worlds untethered to stars, drifting through the eternal night. Without the radiation of suns to sterilize them, could such planets harbor life in subsurface oceans warmed by dark matter's decay? It's a wild idea, but Dragonfly 44 has a way of inspiring them. In the end, this shadowy giant forces us to confront how little we truly see. The cosmos might be teeming with dark galaxies, their presence felt only by the subtle tug of their gravity. Dragonfly 44 is a reminder that the universe writes its stories not just in light, but in absence, a whisper of all we have yet to discover, hidden in the spaces between the stars. In the vast static of deep space radio waves, astronomers recently stumbled upon something utterly perplexing: massive rings of energy so enormous they dwarf entire galaxies, yet so elusive they vanish when viewed through traditional telescopes. These are odd radio circles, or mysterious celestial halos detected only in radio wavelengths, each stretching hundreds of thousands of light years across. Imagine a smoke ring blown by a giant but scaled up to cosmic proportions, floating in the darkness with no clear origin or explanation. Their discovery in 2020 by Australia's ASCAP radio telescope was a fluke. Scientists were mapping the universe's hydrogen emissions when these ghostly rings appeared, perfectly circular and utterly unlike anything seen before. Theories about ORCs range from the plausible to the borderline fantastical. One leading idea suggests they're shockwaves from cataclysmic events, perhaps the aftermath of two supermassive black holes merging, sending ripples through intergalactic gas like a stone dropped in a pond. Another proposes they're remnants of gargantuan stellar explosions, 100 times more powerful than any supernova we've witnessed. But here's the twist: ORCs don't match the profiles of known shockwave remnants. They're too symmetrical, too isolated, with no visible source at their centers. Some researchers even speculate they could be throats of wormholes, Einstein-Rosen bridges funneling particles across spacetime, though even proponents admit that's a cosmic long shot. What makes ORCs so bewildering is their selective visibility. Switch from radio to optical, infrared, or X-ray telescopes, and they disappear entirely. No stars, no gas, no trace of the violence that should accompany such energy. It's like seeing the ripple but missing the splash. This invisibility suggests ORCs might be relics of events long past, their visible components faded, leaving only these faint radio echoes. Or perhaps there's something entirely new, a previously unknown phase in galactic evolution, where galaxies shed their atmospheres in colossal, ring-shaped bursts. The plot thickens with their distribution. ORCs aren't scattered randomly, they seem to hover near galaxies with active supermassive black holes, yet none of those black holes show current activity violent enough to spawn such structures. This implies ORCs might be the universe's version of a dormant volcano's caldera, a scar from eruptions that ceased eons ago. Alternatively, they could be the fingerprints of dark matter interactions, where invisible particles collide and release energy in these peculiar, ring-shaped patterns. Every new observation deepens the mystery. Recent studies reveal some ORCs have strange, layered structures, multiple concentric rings, like a target painted in radio waves. Others show polarization, hinting at powerful magnetic fields weaving through them. With fewer than a dozen confirmed ORCs so far, each discovery feels like collecting pieces of a puzzle without the picture on the box. Upcoming telescopes like the Square Kilometre Array promise to hunt more of these enigmas, potentially revealing whether they're rare cosmic accidents or threads in a larger, hidden tapestry. Beyond the scientific intrigue, ORCs represent something profound: the universe's stubborn refusal to be fully known. Just when we think we've catalogued the extremes of cosmic phenomena, it tosses another curveball, this time in the form of invisible, galaxy-sized rings. Whether they're shockwaves from unseen wars between black holes, echoes of extinct galaxies, or portals to realms we've yet to imagine, one thing's certain: ORCs remind us that the cosmos still holds cards it hasn't played. And in their silent, radio wave glow, they whisper the most thrilling question of all: what else is out there just beyond the edge of our perception? From vanishing stars to rogue black holes, from diamond planets to galaxy-sized ghosts, these 25 cosmic enigmas prove one thing. The universe is far stranger, far wilder than our textbooks ever dared to suggest. Each one of these events isn't just a curiosity. It's a crack in the facade of our understanding, a reminder that the cosmos thrives on shattering expectations. Think about it, astronomers once assumed black holes came in just two sizes until the unicorn waltzed in. They thought galaxies needed dark matter to exist until Dragonfly 44 laughed in the face of that rule. Even the vacuum of space itself isn't as empty as we believed, not when ORCs paint invisible rings across the void. What's beautiful about these discoveries isn't just their spectacle, it's how they force science to evolve. Every time a star defies death like a cosmic zombie or a quasar trio breaks the rules of cosmic evolution, scientists don't just shrug, they go back to the drawing board. They ask better questions, they build better telescopes, they rewrite models that seemed unshakable just years before. That's the heartbeat of exploration, not the answers we cling to, but the mysteries that keep us humble and hungry. So here's the real question for you. Which of these events rocked your world you the most? Was it the wow signal, a whisper from the void that might have been aliens? Or the great attractor, a gravitational puppet master we'll never fully see? Maybe it's the eerie silence of the Boots void, a desert so vast it defies logic, or the cosmic hand, a nebula sculpted by a pulsar's magnetic artistry. Whatever it is, let that wonder sink in. The universe isn't done surprising us, not even close. If your brain's buzzing with questions, you're in the right place. This is just the beginning. Every week, we dive deeper into the cosmos' weirdest, most awe-inspiring corners, from forgotten anomalies to breaking discoveries that rewrite the rules. Hit subscribe, ring that bell, and join us because the next cosmic revelation is already out there, waiting for someone to look up and ask, what the heck is that? The universe has answers, and trust me, they're weirder than anything we've imagined so